Our topic today is lateral movement by threat actors, or east-west traffic. We have heard this a lot, by the way, and there's a lot of players in the market that work in this environment. So we all know this is a major issue in protecting your environment, and I'm going to start with you, Mike. What have you heard enough about on the topic of preventing lateral movement, and what would you like to hear a lot more?
I don't know that I quite hear this as much, but it certainly was vogue for a long time, and you still hear it every now and then, which is the idea that you need to re-architect your cloud network in order to route all the traffic through a choke point. Like that was the concept of how you would get visibility into east-west traffic in your clouds was, hey, break all of your resilience and route all of your data through this one choke point. Isn't that great? But hey, you've got visibility now. So we're not hearing it quite so much, but you still hear that from time to time, and that just needs to stop. That really needs to go away. It's dangerous. It's bad advice. What I would like to hear more of is how do you bring that visibility into what's going on inside the networks, but not just lateral movement. The lateral movement is really, that's the bad stuff. That's the things you really don't want. But you also need to know about how services communicate with each other. You need to know about how the data moves within the environment. You need to know what is normal so that you can really start to pick out what is that negative, what is that bad lateral movement.
I throw this one to you, Sandy. I'm going to ask the same question. What have you heard enough about with regards to preventing lateral movement, and what would you like to hear a lot more?
I hear enough about, again, the bad lateral movement and tying that or attributing ransomware to lateral movement. Ransomware has just been getting this crazy press, and we get it. Us blue teamers have been lacking. We get it. We were very much too focused on layer 8 and users accessing applications and building up a perimeter, and networks ended up being flatter than a pancake. When we tried to take those building blocks, those foundational building blocks, and then move them into any sort of cloud environment with those choke points Mike mentioned, now you're just asking for it to collapse and implode on you and get latency and all these other weird steering of traffic and U-turns and all of these other things. What I want to hear more of is understanding those relationships, not just users and access into machines, but machine to machine as well. And not just the bad, because again, not all lateral movement is bad. It has to happen. So this is one of the reasons why that I want to hear more of why supply chain needs to be recognized as another threat vector. What are companies doing to iterate and continually look at their third-party risk assessments? And are they going to have, sort of a foundation or a mandate to say, okay, we kind of look at everyone outside of ours or even insider threats as a threat. So how do we grade that? How do we look at things more on a risk than act on an alert or wait for an alert to come through?
So it's more of a sort of watching risk priorities going up and down. Yes, Sandy?
Correct, yes.
So can you give me a little bit more insight on that and maybe what you guys are at VMware are doing with regards to this?
Yeah, absolutely. So when new machines spin up, obviously at VMware with things virtualized, we get tens of thousands of workloads that spin up, and they don't live long. They last maybe a couple days, maybe the week, or even a couple hours. So having our SOC, our internal SOC, act on those alerts, it just becomes very, very overwhelming. And it's also waiting for something to happen. So what we try to do is take a very proactive approach. And we have this concept called blast chambers, where if a developer wants to do something or spin up something new, it goes into like this isolation chamber where it's able to still communicate at a minimum and do what it's able to do. So it's very much segmented from everything else. And then once it passes all the sanctions, it gets the appropriate security tag, and then it gets engulfed into the security policy that's appropriate. So it actually gets more.
I'd like to know a little bit more of the mechanics of how this quote blast chamber works, because I like the sort of the image of this and what you're creating. So what is exactly happening here?
Yeah, absolutely. So when a developer actually spins up, let's say an application or a host or anything on it, it has to pass certain criteria. If it doesn't, it gets put into this isolation chamber or this isolation.
So give me an example of a criteria that would trigger it.
So obviously a lot need like access, like HTTP, DNS, things like that. So get that basic information. But if it doesn't have the appropriate tag, like when the builder puts the security tag on it, whether it's in the cloud, so you have your network security group, or the tag within, what we have within VMware, if it doesn't have that appropriate tag, then it gets put into that chamber and more of like a monitor watch mode. Because again, we don't know if it's going to be living long or living short, or what the actual use case for that's going to be until we get more telemetry on what it's actually doing. And since where we sit within NSX is on the hypervisor itself, we don't have to wait for network packets to actually be transient or move around to understand what the traffic is. We're living where the workload is. We're able to identify what it's dependent on, what applications it's going to be talking to, the configuration, the OS it's on. We already have all that data to kind of make a decision and base what that risk is, or, what that risk score is going to be. And that's going to include things like, what OS is it running? Is that vulnerable? Are there any CVEs tied to the processes it's running? If it's running Apache or Nginx, or what version, what CVEs are going to come back for that, and how vulnerable is it?
Sandy, give me an idea of like the before and after when you're not using this kind of sandbox environment and when you are. What is the activity that changes, I guess, for the SOC? Would be the people that would be most affected.
Sure. So traditionally, and as it works for most folks, they spin up a host as long as it has the appropriate OS and the activity it needs from, again, HTTP, DNS, the callouts it needs. Typically, moving east-west, so being able to hop to another machine or ping a resource on the same VLAN, that's typically allowed. Because again, needing that access or API calls, or having to pull a script, or some sort of configuration data, if they run playbooks or any sort of automation, they need to be able to talk east-west and freely. So again, that's why lateral movement is such a huge thing, because it's an attack vector, and as soon as an adversary lands on a machine, they're able just to move laterally throughout because that segmentation doesn't exist. So with what VMware has moved to with their InfoSec team, it's actually being able to spin up a machine where it's isolated within its own VLAN and it's not able to communicate east-west. Again, it doesn't need to know why. We need to know why it needs to be validated. And if those tags aren't appropriate as the machine is spun up, and this is something through what the developer does, or even through the change control process that is also automated through the ITSM, it's not going to be able to communicate or go anywhere. So again, if it only needs to live for like 10 minutes or a day, needs to, if it's something for R&D, or if it's something that's just more of a QA thing where they just wanted to test something and they don't need that east-west access, then there's a script that runs, and that machine also, or host, may get killed because again, it's utilizing resources. So that's another big thing, is being able to tag it and say, I need this machine up, I need it living, it's doing production, it's doing all the things, versus, oh, I just kind of forgot about this machine and it's just living out there in the world alive.
Which, by the way, that happens a lot, I know.
It happens very much a lot. So just being able to manage those assets and tie a risk back to them and see whether or not it's still being utilized, recognize it, and understand the flows. Again, it's not only how users access it and maybe accessing that application or doing whatever on it, but what other calls is it making? Is it using PowerShell? What other APIs is it doing? Is it being monitored? Things like that.
Let me throw this to you, Mike. Mike, what's your reaction when you hear Sandy describing this environment? How would this change your situation?
I think it's a great idea. What it would change for many companies is that ability to rapidly iterate in development, where you can spin up a thing, you can have the resources that you need to test it outside of your own laptop, for instance, and you can get an idea of what it's going to look like in a production environment, but in a safe way. And then it sounds like there's a great way to then progress through the gates where you can stand up a thing, you can satisfy the security requirements, and then it graduates into broader participation in the environment, potentially without ever having to get a manual security review. You know what the gates are, you know what you have to do, you have a path to do it, but you're able to start off in a safe environment and then end up in the production environment in a safe manner without necessarily having to have manual review that kind of slows down your development process.
Did Mike describe that well, Sandy?
He did. Yes, exactly.
I'm very proud of you, Mike.
Oh, thank you.